Welcome back to Big Picture Statistics and Computer Analysis. Today we want to look at hypothesis testing for the mean, in which the standard deviation is unknown. For this we will use a t-test, and in this section we'll talk about one sample t-test in particular. So the guidelines are as follows, and these guidelines, you can use them as a template for other tests as well. The first thing, the level of significance alpha is specified. The degrees of freedom are n-1, n being the sample size. With alpha and the degrees of freedom, we can use the t-table, namely this one, and we can obtain critical values by using this table. And then we have to make a determination about left, right, or two-tailed test. One of these three. These will be determined by the alternative hypothesis. If the alternative states that the mean is less than a specified value, it'll be left-tailed. If the alternative states that the mean is greater than some specified value, it'll be right-tailed. And if the alternative hypothesis states that the mean does not equal a certain value, then it will be a two-tailed test. And one of these diagrams we would pair with whichever test we decide to do. And all of this is determined strictly by the alternative hypothesis, not the null hypothesis. Alright, now, what we want to do, when all of that is done, we have to calculate our test statistic, given by this formula. And like before, we have to see whether that test statistic lands in the shaded region, determined by the critical value, or if it doesn't. If it lands in the shaded region, we will reject the null hypothesis. If we don't land in the shaded region, we will fail to reject the null hypothesis, as is summarized here. So let's look at an example with a one-sample t-test, one that leads nicely to using SPSS. Alright, let's take, for example, one of these problems here. Let's see, we need one with a good data set. Let's take the annual salaries problem. This one here for number 25. An employment information service claims the mean annual salary for senior level product engineers is $98,000. The annual salaries in dollars for a random sample of 16 senior level product engineers are shown in the table at left, this table right here. At alpha equals 0.05, test the claim that the mean salary is $98,000. So we're testing the claim that the salary is $98,000. That is an alternative hypothesis. Actually, that's not an alternative hypothesis, that's a null hypothesis. This is a null hypothesis, so the null hypothesis is the claim. The alternative is that the mean is not equal to $98,000. So in this problem, the claim is the null hypothesis. Now, to do this problem, we want to go straight to the SPSS. But before we do that, let's determine our rejection region. We're looking at a sample of 16 salaries. So the degrees of freedom, n minus 1 is 15. 15 degrees of freedom and alpha 0.05. And remember, we are doing a two-tailed test. So area on one tail is actually half of that 0.05. It's 0.025. So we are... Let me see. Alpha is 0.05. So yeah, 0.025 is the area on one tail. The area on both tails is going to be 0.05. So we're in this column, and we're going down to 15 degrees of freedom. The critical value is going to be 2.13. Now, this is a two-tail test. So actually the diagram is like this. So one of the critical values is this 2.131 that goes here, negative 2.131 goes here. The shaded regions will be the rejection regions. So let's go back to that. And what we're going to do, we're going to take this data set, we're going to enter it in SPSS. So let me do that for you. Let me open SPSS. Let me open for you a new data file. And very simply, I will enter the data for you in here, just the way it was written out. So here we go. The first salary was 100,651. Now you can go by rows or by columns. Let me do it by columns. So I'm just entering the salaries one by one. There we go, we entered the data. Just go to the variable view. We'll go to scale level. We'll just call this salary. Okay, we don't have to create labels. We don't have to do any of that. Alright, so let's go back to data view. Let's go to analyze. We'll go to compare means. One sample t-test. It goes here. And test value, the test value was 98,000. So we enter 98,000. Now let's just take a quick look at options. Alright, confidence interval. No problem. Let's go to OK. Alright, so there we go. It's basically giving us a test statistic of negative 1.872, and the critical value that we had was 2.131 and negative 2.131. This is in between those two values, so it would land in the unshaded region. And if we're in the unshaded region, we fail to reject the null hypothesis. The null hypothesis was our claim. And if we fail to reject the claim, that means there is not sufficient evidence to reject the claim. And that's it. That's basically your one sample t-test in SPSS.